My dear students, today I am going to teach you the invertible function. This is a very important topic of a 12th class relation and function chapter, and this is a part 5th of this chapter. So invertible functions, a function f such that x tends to y is said to be invertible if there exists a function g y tends to x such that g o f x is equal to I x and f o g y is equal to I y. Understand here, this is a function f, x tends to y, and this is a function g, y tends to x. Opposite of this, x tends to y and y tends to x. This function is the opposite of this, and we have to prove that this function is opposite of this, inverse of this. For inverse, we have to prove these two conditions: g o f x is equal to I x and g f o g y is equal to I y. So these two conditions, if are proved, then the function g is f is the invertible function and g will be the inverse of f, and it can be written as g is equal to f inverse. If these two conditions are satisfied, the function g is called the inverse of f and is denoted by f inverse. G is equal to f inverse. I think you have understood this definition of invertible function. So I am taking example. With the help of example, you will get the actual knowledge of invertible function. First example. First example. In first example, f is any function f n tends to y. Be a function. This is example first. Example first. F such that n tends to y be a function as f(x) is equal to 4x plus 3, where y is equal to y belongs to n such that y is equal to 4x plus 3. 4x plus 3. For x belongs to n, so that f is invertible function. This is the question. We have to prove this function is invertible function. So take this function f such that n tends to y, where x belongs to n. Now what is the condition in this? Fx is equal to 4x plus 3 and fx is equal to y. Y is equal to 4x plus 3 because fx is equal to y. This is the value of y. Now second function g. G is equal to y tends to n, opposite of this f. where in f function this is the condition fx, in g the condition is gy. What is gy? We have to find out the value of y from here. That is y is equal to here we have to find out the value of x. Y minus 3 upon 4 is equal to x. From this value of x is this, and gy is equal to, here see, fx is equal to y and gy is equal to x. It means gy is equal to x and gy is equal to, what is the value of x? Y minus 3 upon 4. This is the function. First of all, you have to find out both the function and their condition. This is the condition. This is the function. This is the condition. This is g function. This is the condition. And by these two conditions, we have to prove f(o)gx and g(o)fx. f(o)gy and g(o)fx. Now, two conditions. Now, two conditions are, first condition, g(o)fx. First condition is equal to g(f)x. As I have told you before in the first part, g(o)fx can be written as g(o)fx is equal to g. What is the value of g(f)x? fx. What is the value of fx? 4x plus 3 as given in the statement. And this is equal to gy. And what is value of gy? Gy is equal to y minus 3 upon 4. Y minus 3 upon 4. And by putting the value of y, what is the value of y? 4x plus 3. This is the value of y, 4x plus 3. 4x plus 3 minus 3 upon 4. 3 to 3 and 4x upon 4 or is equal to x. This is the first condition. Now second condition. Now second condition, f(o)gy. Here listen to me very carefully. If you write the function g(o)f, you have to write down the x, because x is dominant in this function and f(o)g, y is dominant in this f(o)g. So f(gy), f, what is the value of gy? Y minus 3 upon 4. This is the value of gy, or this is equal to fx. And what is the value of fx? 4x plus 3. And by putting the value of x here, what is the value of x? This is the value of x. 4 y minus 3 upon 4 plus 3. Again 4y minus 12 upon 4 plus 3, and this 4 can be cancelled with this 4. So therefore y minus 3, make it a simple, y minus 3 upon 4 plus 3. 4 is cancelled. This is it. Here, for simplification, see this step. 4 is cancelled with 4, and y minus 3 plus 3. This cancelled with this, and this is equal to y, and this is second. Here, g of x is equal to x. Here, f of y is equal to y. Hence, both the conditions are proved. G O f x is equal to x is equal to I. F O G y is equal to y is equal to I. This implies that f is invertible. F is invertible function. F is invertible function, and g is the inverse of f. Hence proved. So now I am going to take one more example. Example second. Example second. This concept will be more clear by this example second. Example second. Let y is equal to x square such that x belongs to n contained in n. This is a function. Consider f such that n tends to y as condition fx is equal to x square. This is the condition. So that f is invertible. So that f is invertible. F is invertible. This is the second example. Now again write the first function f, and n tends to y. This is the function. And what is the condition? Fx is equal to x square. And what is the value of fx is equal to y? Y is equal to x square, because x is equal to y. Now find out the value of x. X is equal to root y. This is the value. This is the value of y, and this is the value of x. As in the first example, you have seen that both the values are very necessary, x and y, for proving g of fx and f of gy. Now second function, g, such that y to n. Change this function, because g is the invertible of x. We have to prove, and condition is, this is in this condition fx, in this condition gy. Mind it. In g function gy, in f function fx. This function in x and this function in y. Because in f, x is dominant and in g, y is dominant. And what is the value of gy? What is the value of gy? Gy is equal to x because gy is equal to x. Fx is equal to y and gy is equal to x. Opposite. See here, gy is equal to x, or what is the value of x is equal to root y. This is the function. Here now gy is equal to root y. Remove this x from here. This is gy is equal to root y. Now we have to prove GOFX and FOGY. We have to prove this. These two conditions. It should be equal to x, ix. It should be equal to y, I. These are the two conditions. We have to prove these two conditions. Here, first condition, GOFX is equal to GFX is equal to G. What is the value of fx? Is equal to x square. What is the value of fx? X square. Here, this is equal to gy. And what is the value of gy? Gy is equal to root y. From this, gy is equal to y. And what is the value of y? Y is equal to x square. Root x square is equal to x. This is the first condition. This is the first condition proved. Second condition, FOGY equal to FGY is equal to F. What is the value of GY? G is equal to root y. Root y is equal to Fx, or is equal to Fx is equal to x square is equal to, what is the value of x? Root y square, and this is equal to y. This is the second. Hence both the conditions root means the function is invertible. By first and second, f is invertible function. F is invertible function, and G is the inverse of f. So these two conditions proves that this function is invertible. F is invertible and inverse of f is G. G is the inverse of f. F is invertible and G is the inverse of f. By these two conditions, this is the condition. Second, this is the second. And write this GOFX is equal to x is equal to IX, identity function. FOGY is equal to y is equal to I line. These two conditions are proved. Hence, this is an invertible function. By these two examples, I think you have understood the definition of invertible. And if you get any question from your textbook, you can solve very easily by this method. One thing I want to tell you more, if any function is 1, 1 and on to, that function will be invertible. And if opposite, conversely, if a function is invertible, that function will be 1, 1 and on to. For this, if you can prove a function is 1, 1 and on to, by the condition also, you can say that this function is invertible. So for proving a function is invertible, you can apply both the conditions, 1, 1 on to and this function, this condition. So my dear students, I will take next part in the next session. And one thing I want to make you a request, please subscribe the channel also.